Okay, so let's begin. What we're going to be doing right now is we're going to be using some existing storm drain pipes that have already been laid out in the plan view. They've already been designed, and we're going to show you now how to actually create storm drain profiles. The first thing that you have to do when you're going to create storm drain profiles in Civil Land Development Desktop is you want to always make sure that your project scale is set properly. And let me do that again so you can follow it. Go to Projects, go to Drawing Setup, and then what you want to do is you want to go and check your scale. Now, as the engineer should tell you, the engineer will tell you what vertical scale and horizontal scale he wants to see the drawing in. So for this drawing, let us kind of sort of determine what our scales should be. One of the first things we're going to do is, because I don't like to look at the drawing, I don't like to look at my text vertical, we're going to actually set it up so that we're looking at it in sort of a plan view style. And in order to do that, we have just set our user coordinate system to storm drain stormwater management 03, which is a user coordinate system which we created earlier. And so we select that. There you go. And then we type the command plan, PLAN, in the command line, and hit enter. And now what you will see is that the entire view has now been rotated so that the drawing appears to be horizontal. Now, it's important to note that the actual drawing itself is not rotated, it's just our view of the drawing. It's the user coordinate system. So if I were to go back and select the user coordinate system SDSWM03, what you're going to see if I zoom in is you can see our positive X right here and our positive Y right there. However, something that's extremely important to note is that as you work with civil commands, as you work with the various tools in Land Development Desktop, the Civil Design module, you cannot work with those tools if you expect to get the proper use of them. You cannot work with them unless you're in the real world coordinate system. So you must be cognizant at all times to place your user coordinate. Okay, so JR just asked the question, if your computer does not have these coordinate system tools on them, how can you get them? What I want to do is drag this toolbar, and what you'll see is this one is entitled UCS2. There's also another one that I just put into my toolbars, and this one is entitled UCS. So we have two separate toolbars. One is called UCS and another one is called UCS2. Those are very, very helpful, but for me, by far, the most important ones that I use are the display UCS dialog box, and you'll see why in a minute. And then the other one that I really use a lot is the 3-point user coordinate system creation tool here. Those are very, very helpful, along with the dialog box here. And you'll see me use those quite often as I work in the drawing. Okay, so this is a storm drain and stormwater management plan. And if you look closely in this plan, it looks like a whole bunch of different lines, but I'm going to explain to you in general what we have. This weekend I spent some time and I designed an underground stormwater management, or at least I sized the underground stormwater management vault. And when I sized that underground stormwater management vault, it came out to be something like this. What we have is a concrete structure that all of the drainage from this industrial site will actually, at least from the front 2/3 of the site, all of this drainage will find its way into this vault right here, and it will be released at a predetermined discharge rate back into a storm drain system that then carries it further downstream into this storm drain system that dumps out into a system further downstream where a trailer park is. And so this system is very important because we cannot just discharge all of this drainage into the downstream area, because it will flood the downstream area if we do so. So we design a control structure where all of this water, when it rains, will wind up into this storm drain system and into this stormwater management vault. There is a control structure of system of orifices and weirs in here that we designed this weekend that will then control the drainage. And so let's go and get on with the business of preparing our profiles. The very first step that you want to do when you're creating some profiles is you got to make sure that you have the proper tools along the top of your land desktop. And what I can see is that I don't see the profile generation pull down, so I need to get it. What I'm going to do to get it is I'm going to hit the project tab, and I'm going to go down to menu palettes, and the next thing I'm going to do is go to the Civil Design 2i module. I'm going to click load, and what you will see across the top is a whole new set of tools that you can use. You'll see alignments, you'll see profiles, cross sections, hydrology, pipes, sheet manager, a whole host of tools here that we use in civil design that is very, very helpful to speed up the process for preparing complete civil engineering plans. So what do we have here? We have the most important tools for creating profiles are the alignments pull down and the profiles pull down menus. Before we start using those, one of the things that we have to do is we have to set our layers. And we're going to type the command LAS for layer set. And then we're going to hit enter. And we should have some command some layer that's already named align, I would think. If not, we'll have to make it. I don't see it in this pull down. So let's hit cancel. And then we're going to bring up the layer dialog box, the real layer, not the quick one, by typing LA. You have to give it a moment to come up. And then you're going to go up here to the name layer filters, and you're going to use wildcards on asterisk. And then you're going to type a align, because that's what we're looking for, any layers with that terminology align. And so I see that some layers that have that, but they are all in our concept drawing. We are working in the storm drain stormwater management drawing, and so we need to create our own layer that's specific to this particular drawing. Now, anytime you see this type of layer name with site concept, what that's telling us is that this is an X reference layer. It's because the site concept plan is actually X referenced into this drawing. So what we're going to do is we're going to make our own layer, and we're going to call it SD Align, and that'll be short for Storm Drain Alignment. So we're going to hit New, and we're going to type SD Align, and now we'll keep the color as white. We'll keep the line type continuous, and the reason why we'll do that is because this layer is not an important layer. This is simply a layer that we will use the lines on this layer to define the actual alignment. So I'll hit OK, and now we're ready to start drawing some alignments. Now it's important to note that when you start drawing alignments, what you want to alignment simply represents a sample line, a line along which a profile will be drawn. And so what you want to do is you want to make sure you capture enough surface to account for your alignment. You want to get profiles that actually show exactly what your storm drain or whatever you've designed really is doing in the plan. And it does no good if your alignment is too short. So we're going to go ahead and we're going to start drawing some polyline. And let me tell you, you always want to use polylines to draw your alignments rather than lines, because when you get ready to define the alignment, you do not have the choice to select line to define that polyline. You must choose to define that alignment. You must choose polyline. So we're going to use the polyline command. Let us start. So what you see here is yard inlet 08. Let me zoom into that so you'll understand. This is a yard inlet, and this is, we call it YI08, yard inlet 08. And that is dumping into a stormwater management vault. And so we need to make sure that we get a profile of that section, of that pipe, from YI08 all the way to the stormwater management vault. And this stormwater management vault is actually number 02. So I'm going to edit this now and go ahead and correct that. And this is number 02, and so we'll call this SW02. So we're going to go ahead and start drawing some alignment lines. Polyline, PL command for polyline, and then we're going to draw the alignments. And as long as it's going through the pipe, it doesn't have to be perfectly centered. As long as it's going through the pipe, we're in good shape. And so it doesn't have to be perfect, it just simply needs to be traveling through the pipe. And so that's one alignment that we're going to call it right there. But you notice how we're still set on the P-SD layer. We have to make sure that we're setting on the right layer. So I'm going to type the layer command again, pull up the layer dialog box, and I'm going to set it current. I thought I had done that earlier, but I had not. So we're going to set it current, and we're going to change this to SD align. Alright, we'll change that to SD align, and now it's set to SD align, and then we're going to go ahead and draw the other alignments for the other storm drains. Polyline, and I'm just going to put them somewhere. I'm going to get them close. Not going to be perfect, but we're going to get them close. Very close. So now we're right there where we need to be, straight down the center line of that one. And now we're going to do the really long pipe run, which includes also the public storm drain system. Type the command polyline, PL, and we're going to try to get this one really close to. And we're going to draw this straight down the center line of our storm drain system. And we're going to extend it. Yes, we're going to extend it beyond the storm drain system. Now you will notice that up top here. Okay, so next what we're going to do is we're going to actually define these alignments. Okay, so what do we see? We want to always keep our same naming convention as our inlets, or as our structures are named. We want to keep our same naming conventions, okay? And what I'm going to do, just for clarity's sake, is I'm going to move the nomenclature for the underground stormwater vault. I'm going to move the naming for that to somewhere here where we can see it very nicely and clearly. And then we're going to start defining these alignments. And to do that, we're going to go to the menu, alignments, and we're going to define from, you can define from objects, you can define from polyline. We're going to select the define from polyline, and you notice right here we're going to select this, and you see the red X. It went away, but there was a red X that came up on this at the very end, and that's your reference point. Okay, that's your reference point. But the reference point actually is the point at which the profile will start. So what we're going to do is, instead of using this endpoint for the reference point, we're actually going to, well, actually we may just go ahead and use it. We'll just go ahead and use it because I don't want to complicate things. Let's just go ahead and use it, and we're going to hit start. You see, we're going to hit start, and the alignment name now is, you have to give it something that you can remember, and I always name it in accordance to the names that I give to the structures. So I will say YI08 to SWV02. Alright, And then you have to describe it. Storm drain pipe from YI08 to vault 02. And we'll hit OK. Now, if I come into here and I begin to inquire, I can inquire now, station offset alignment, and watch this. Now this tells me, if you look at the bottom of the screen, that I'm 5.58 feet from the end, or from the starting point of this alignment. And now if I come here, and it'll also tell me that I was offset about 0.25 feet to the left or negative side of it. Okay, so now anywhere along that alignment, I can know my station, and you'll see where this was going to become very, very helpful pretty soon. So now the face of that is at 77.83 feet, and so it's going to become very, very helpful pretty soon. Okay, let's move on to the next one. All right. Now what we're going to do is we're going to define the alignment for the pipe storm drain run from Y06 to Y07 and down to stormwater management vault number 2. And let's get started. And we're going to start our profile. In this case, we're going to start it from this end, because we're going to be moving from left to right in our profiles. And so we're going to start it from this end. So let's go ahead again to the top, define from polyline, select it, and as you can see, this is the red X that I was referring to before. It'll come up to let you know that that's your reference point. Hit start, and now this alignment name is YI07 to YI06. Right? Storm drain pipe from yard inlet 07 to yard inlet 06, and we hit enter, and we're good. And what we see now is that alignment, it started at station 0 plus 0 and it ended at station 200 plus 11.0, and that tells us that this alignment is 211 feet, 11.04 feet long. Now let's do the next one, which is the very long one, and this one is the actual outfall pipe from the stormwater management structure. And this one is the one that will be carrying our drainage away from the site and downstream, and dumping into an existing cross culvert, which then dumps into a storm drain system at the trailer park. And so what we're going to do now is create that alignment. So we're going to start this one from vault 2, and we're going to wind up all the way down to manhole 01. So that will be the name of this, from vault 2 to manhole 01, or better yet, we can call it the outfall pipe. Okay, but I'm going to keep it with the proper nomenclature in this situation so that we'll never get confused. So we're going to select that polyline, and you see the red X comes up, and that defines the beginning or the reference station. I'm going to hit enter, and now we have to give it a name. We're going to say outfall underscore stormwater vault 02 underscore to manhole 01. Okay, and I'm just going to put a description of outfall storm drain pipe, and I'm going to hit OK, and that one is now defined. It's 482 feet, 82.77 feet long. So now that our alignments have been defined, now the next thing, the most critical thing now that we need to understand and know is how deep are the pipes going, or how much vertical span we need to actually capture the actual profile. In other words, what I'm saying is we need to know the highest point in the profile as well as the lowest point in the profile. And so we're going to start with the last alignment that we created. And what I know, because I'm the engineer, I designed it, I know is that this alignment, for the outfall pipe alignment, the highest elevation that we're going to have in this alignment is actually somewhere between 262 and 263. So I'm going to say 263.5. 262.5. And I also know that the lowest point in our profile is literally at manhole number 1, where we have this, the invert of this pipe is going to discharge into this cross culvert at about elevation 240.73. Now I've already done the calculation, and what I know is that that's a vertical span of about 22 feet, 21.77 to be exact, but about 22 feet is the vertical span. So now one of the things that I find helpful is I always take an engineer scale and I try to find out what vertical scale will be most useful. A vertical scale that will not take up so much of my paper, but will give still enough vertical exaggeration so that we can actually see the change in grade, the change in slope, and understand what direction the pipe is flowing. So in this case, even though I don't like to do it, what we're going to do is we're going to select a horizontal scale, because our plan actually plots well at a horizontal scale of 30. 1 inch equals to 30 feet, and we're going to select a vertical scale of 1 inch equals to 4 feet. Now I did not choose, although it's typical that we do choose scales of like horizontal 30 inch equals 1 inch equals 30 and vertical 1 inch equals 3. The 3 scale would definitely be too much paper taken up, too much of the sheet taken up with the vertical exaggeration. So we don't need that. Only thing we need to do is show enough vertical exaggeration so that we can so that folks can see that the pipe is sloping downward. So what we're going to do is go back to projects, drawing setup, and we're going to set our scale. You see it's already set actually. Horizontal scale 1 inch equals 30, and vertical scale 1 inch is equal to 4. Okay, so with that set, now what we're going to do is, it's nothing more frustrating than trying to create a profile, and then once you create it, once you go through the headaches, and then the computer tells you that you don't have some surface there to sample. So one of the first things I always like to do is I like to make sure that, number one, I'm in the real world coordinates, user coordinate system right over here, and we are. And then number two, what I'd like to see is a copy of, or a display of the actual DTM, how it falls out over top of my plan. So I'm going to go to terrain, and I'm going to go to set current surface, and I want to set the existing conditions or existing ground. This is what we surveyed, and I'm going to set that surface as my current one. And then what I'm going to do is I'm going to do a quick view, because the quick view command does not import the surface lines into my drawing. It just lets me see where the surface is located. So we're going to go quick view, and all of a sudden now we see the surface. It pops up right where it's supposed to be, and we know that when we sample along our alignment, we're going to come up with some good data here. So this is what it is. All right. So, and notice also that when I pan around in my drawing after the quick view has come up, it goes away. So that's why we like to use quick view, to make sure that our surface is right over top of our alignment. So without further ado, now what we're going to do is we're going to go ahead and get on with the good thing, with the beautiful thing here of preparing the profile. So we're going to go to surface. Always just get in the habit of doing this. Set current surface, existing conditions, right? And if you had a proposed conditions surface after you've done the grading and you had a new surface, then you select that surface, okay? And then you say existing ground, and you say sample from surface. All right, so now we have a menu that pops up. We have a sample offset tolerance that comes up here, and this by default is always set to 0.5. I have no problem with that, because if my sample line gets within 6 inches of what we show here, then I'm okay with that. That's not too off. Some people like to set it to something a little more tighter, and I can do that, and I can set it to 0.25, which is essentially 3 inches. And so we can set it to 0.25, and we'll be okay either way in my mind. And left and right sampling. Now, for storm drain profiles, we don't really need to do left and right sampling, because we don't really care. This is all buried. Now, if I was designing a road, I would care if I would care to bring in the left and right sample lines. I would want the profiles for the left and right sample lines at some distance at the right-of-way line, whatever the right-of-way line. If it was a 60-foot right-of-way, I would set each one of these left and right offsets to 30. And what that will do for me is ensure that when I lay out my finished grade center line, that I'm not laying it out so that I'll have to build retaining walls, and I can minimize the amount of grading. But in this case, I don't really care about it, so I'm just going to click OK. And now what you'll see at the bottom is it says beginning station 0 plus 0, 0. We want to sample the entire length of our profile, of our alignment. So hit enter, and the ending station is 482.77. Hit enter, and you'll get a nice notice that says you have sampled profile for 482.77 feet of alignment. This tells me that we have sampled the entire length of the alignment. And now the next thing we do, we come in here and we'll tell the computer to create full profile. But I'm not going to do it yet. And the reason why I'm not going to do it yet is because one of the things that you need to always remember about Land Desktop is that the profile will come in at a world user coordinate system world, but also in a view of the user coordinate system world. So it'll be nice, it's best actually for you to come in here and type set first your user coordinate system to world, and then type the command plan, PLAN, and now it's going to rotate the view so that your profile is going to come in properly. And so what we want to do, we've already sampled it, and we want to come somewhere off the side, somewhere in our plan. And I'm going to go down a little bit further down here, because I know that in our road improvement plan we had about 20 cross sections that we created this morning, and so I want to make sure that they're not sitting over top of one another in our project. Okay, and so I'm going to go to profiles, create full profile. Alright, and you see we have here start range, start at station 0, 0, and end at station 482.77. That's fine, I'm okay with that. We have a minimum elevation of this profile, and this is, remember what we said before, we need to know what the lowest elevation is and the highest elevation. Now what you'll see on this dialog box is that the minimum elevation is 250.19. Well, one of the things I know is that's not true, because this is just simply showing the elevation of the existing ground. It takes no account for the actual depth that the storm drain pipe will be in the ground. What I know is that the storm drain pipe is sitting at the lowest elevation of the storm drain pipe is at elevation 240.73. So I know I need some more profile depth. So I'm going to change my datum for the profile to be at around elevation 235. And the vertical scale is already set, and the profile will be created traveling from left to right. And yes, we do want to import the grid, and what I'll do is I'll leave these numbers the way that they are. And the grid height, if I start at 235, and the grid height will wind up being at 26.67, if I just simply add those numbers up right there, and 235 plus 26.67, that tells me that I still need some more grid height, because remember what we said, the height of our ground, the highest part of our ground is going to be at around elevation 262.5, so we need to give it some more height, and I'm going to give it about 5 more feet of height, and I'm going to change this grid height to 32. And then I'm going to hit OK. And now it's asking me for a starting point for my profile. And now it's going to actually import the profile into the plan. And then I want to, if you want to get rid of all of the layers in your drawings where other profiles have been created, then yes, you want to say yes, delete existing profile layers. But it's always a wise thing to do your own deleting instead of letting the computer do the deleting, because you may delete something that you don't want to delete. So I always say no by habit. And now what you will notice is we have a very nice profile of the ground that's come into our drawing.